Hello friends and welcome to CEC live lectures. In the ongoing lecture series on extraction of natural products, we were discussing about supercritical fluid extraction technique. And in my previous lecture, I discussed about the instrumental part of this technique, wherein we discuss various components that are used to set up a supercritical fluid unit. And in that we discuss about the vessels that are used in this extraction unit. Obviously, we discussed there are different types of vessels depending upon their utility, such as extraction vessel, separation vessels, and product vessels, and so on and so forth. We also discussed that depending upon the utility of that vessel, we have to design that vessel, and the material, the thickness of the material sheet that is used to manufacture these vessels have to be taken into account considering the utility of those vessels. We also discuss about the relationship between the pressure at which the extraction has to be carried out vis-a-vis the thickness of the vessel that has to be used, and also we discussed the relationship between internal diameter of the vessel with respect to the thickness of the vessel that has to be used in the extraction unit. We also discuss about certain closing systems for the vessels, wherein I highlighted about the ring closures and the clamp closures, and what is the major difference between the ring and the clamp closures. So friends, in continuation with this lecture series, today I am going to start with the second component that is required in setting up the supercritical fluid extraction unit, and the second component is the pumps and compressor. Now, pumps and compressors are considered as the heart of the supercritical fluid extraction unit because these are the components that are required to maintain the pressure as well as flow of the solvent throughout the extraction process. Now, as we discussed that the supercritical fluid extraction process involves variation in the pressure depending upon the sample that has to be extracted. So some samples require a bit lower pressure, some samples require a bit higher pressure. So we can say that the pumps which have to be incorporated into this unit, they have to work at a varied pressure and a varied flow rate of the solvent. And moreover, the flow rate, which is largely from 5 to 120 liters per minute, this variation of the flow rate that is required and that varies from sample to sample, this flow rate has to be maintained at a very high pressure that is required during the extraction process. And by and large, we have seen that this pressure also varies from 6 to 65 megapascal. So when you have to maintain the flow rate of a solvent at such a high pressure, one has to be very critical in designing these pumps and compressor if they are to be exposed to those extreme conditions. Now, if we talk about the basic mechanism of the pumps and the compressor, we can categorize the pumps into two major types: multi-plunger type of pumps and the diaphragm pumps. Now, as the name indicate, multi-plunger pumps, they have multiple plungers in their structure which keep on pumping the solvent or which keep on reciprocating with each other to provide a flowless or a pulseless flow of the solvent, and also they help in maintaining the pressure. Whereas diaphragm pumps, they work on altogether different mechanism, and the major difference between multi-plunger and diaphragm pumps is the use of lubricants. Multi-plunger pumps, basically they have to work in a frictionless manner in order to provide a pulseless flow, and therefore the material that has to be used in manufacturing these multi-plunger style pumps, that should have a very low frictional coefficient. Further, since we cannot use the lubricants in pumps because of obvious reason of contamination of extract or solvent with the lubricants, one has to be very critically select the material. Obviously, one parameter is the low coefficient of friction, and second is whatever material you are using in making the plungers, that should withstand those high pressure and temperature condition. It should not expand, it should not contract, because whenever the pressure is increased or temperature is increased, there is every possible chances of expansion of the material that is used to make the plungers. So one has to be very careful in selecting these materials. On the other hand, compressors are required for a proper flow rate as well as for maintaining the pressure. And again, we have reciprocating piston types and rotary compressors. Now, in today's scenario, largely reciprocating pistons are used in compressors, and rarely we go for the rotary compressors. Now, as I told you that these pumps and compressors have to work at a very high end pressure conditions, and therefore they should be able to withstand, and they can maintain those pressure and flow conditions under the extraction conditions. And amongst temperature, pressure and flow rate, pressure is most critical factor, because pressure, if there is any kind of fluctuation in the pressure during the extraction process, it leads to substantial difference in the results of the overall extraction process. We know that pressure is a critical parameter in supercritical fluid extraction, because it is the parameter that helps in maintaining the density of the solvent. So if there is any fluctuation in the pressure values that are required for the extraction process, it will lead to variation in the extraction results. And sometimes such fluctuation also cause overpressuring of the devices, and we all know the implications of overpressure whenever there is this kind of overpressure in the system. Then control systems are there, they will immediately cause shutting down of the process. Sensors are there, they will sense the overpressure of the system, and they will stop the system. And once the system is stopped, we are going to waste the solute, that is the raw material which we are using, the solute that have already been extracted, and also will be losing the supercritical solvent which we are using, and all these factors will lead to the poor production rate or poor yield of the extraction process. And once the extraction yield is affected, the cost factor comes into play, and all these factors, that is loss of solvent, loss of raw material, decrease in extraction yield, and obviously damage to the system which can be done by the overpressure, all these factors increase the overall cost of the extraction process in terms of the cost penalties that will occur due to these changes. So one has to be very critical in designing the pumps, in designing the compressors, so that they can maintain the required pressure, they can maintain the flow rate, they can maintain the temperature throughout the extraction process. Now in this picture you can see the image of a multi-plunger pump that is designed to the maximum pressure limit of 96 megapascal and a flow rate of 30 kgs per minute. This is an industrial scale multi-plunger pump that is used by an industry for a supercritical fluid unit. Now, as I told you that plungers should never be lubricated, because these lubricated material can lead to the contamination of the solvent, they can lead to the contamination of the extract. So therefore, whatever material that is used to make these plungers should be selected critically, having low coefficient of friction, and it should be able to withstand the high pressure and temperature condition. It should not expand, should not contract, because these expansion and contraction may cause leakage of the pressure, they may cause leakage of the solute extract, which can further damage the system. Various types of rings, gaskets and seals that are to be used in making these pumps, there again their design should be very they should be critically designed. The material, whatever being used in making these gaskets and seals should be compatible with the solvent and solute. There should not be any kind of interaction between the solvent and the solute. The material should not absorb the solvent. It should not absorb the solute molecules or the solute from the extract. So one has to be again very critical, and these gaskets and seals and rings should be designed keeping in mind the basic purpose of the extraction unit, the basic pressure and temperature conditions that are required in this extraction unit which we are designing. The next component is the heat exchanger, and we discussed that heat exchangers are largely used to maintain the temperature conditions of the solvent of the extract. And these heat exchangers are largely found either before the extraction vessel or immediately after the extraction vessel and before the separator, because as I told you that they are meant for maintaining the temperatures, they are meant for decreasing or increasing the temperature. So in separating vessels or before separating vessels, they help in decreasing the temperature, thereby decreasing the density as well as the temperature of the solvent, which helps in separation of the solvent from the solute. Whereas if they are placed before the extraction vessel, these are required to maintain or preheat the solvent before it is entered into the extraction vessel. Because of their critical function, very limited designs are available in the market, and because the extraction units are to be used at a very high pressure, therefore heat exchangers have a very limited design in the market. But whatever exchangers are there, every design is a proprietary design that is being manufactured by the manufacturers. Now, as I highlighted that heat exchangers are very critical in the supercritical fluid extraction unit, because if there is any kind of failure in the function of heat exchanger, it may lead to certain problems in the extraction unit. Like if there is any kind of leakage of the temperature from the heat exchanger, that is they are not able to maintain the temperature, it may create certain ice plugs into the unit. And this kind of ice plugs will lead to the freezing of the heat exchanger fluid. The fluid that is being circulated through the heat exchangers to maintain the temperature, whether to increase or to decrease or to maintain the prescribed temperature, if that fluid freezes, the basic purpose of the fluid, that is to exchange the temperature to maintain the temperature, will not occur, and therefore it will cause damage to the heat exchanger. And once the heat exchanger stops functioning in this manner, it leads to the overpressuring of the system. And this overpressuring, as we discussed, may cause damage to the tubings, it may cause leakage from the seals or from the gasket, and once the pressure is increased, again the control system comes into the picture and it will shut down the whole system, thereby causing the loss in the form of the amount that is involved in raw material or the solvents. And therefore, by and large, removable heat exchangers are preferred. So if there is any kind of problem in one exchanger, it can be easily replaced by the new one or the already repaired one. Now, the whatever tubings that are involved in manufacturing the heat exchanger, the number of the tubings, the diameter of the tubings that are involved in setting up a heat exchanger is very critical. And these are the important parameters for selecting the heat exchange or the heat exchanging unit for an extraction system. Because if we are using tubes of less diameter, then obviously to attain the full efficiency of the exchanger, we have to increase the number of the tubes. And once we increase the number of the tubes, the cost factor increases. One. Second, as soon as we increase the number of the tubes, we have to imply more joints, we have to imply more couplings into the system, which will again are a major source of malfunctioning of the unit. Another important problem with the small diameter tubes is the cleaning aspect of these tubes. Smaller the diameter of the tube, greater will be the efforts to clean those tubes. And therefore, by and large, the appropriate diameter tubing should be used whenever we are designing a supercritical fluid extraction. The larger diameter tubes help in proper flow of the solvent. They do not pose any kind of cleaning problems, and they can be accommodated in a smaller space, because the number of tubes now will be less if you are using the larger diameter tubes. But still, the bottom line is one has to be very careful in optimizing the diameter of the tubes that are to be used for the heat exchangers. There are different types of heat exchangers that are commercially used, and these are shell and tube exchangers, double pipe exchangers, multi-U tube exchangers, double pipe coil exchangers, and the simple coil intact exchangers. So every exchanger has its own usage, and they are used for specific purposes. So depending upon the requirement of your process, one can easily select the most suitable type of heat exchanger for their unit. Now we move on to another component, that is piping and the valves. And we have seen various pictures of the supercritical fluid unit where we can easily see that various extraction vessels, various vessels that are used in the unit, various storage tanks that are used in the unit, they are all connected by the piping and the valves. And therefore, once you are designing the piping and the valve, the material that you are using for manufacturing these piping and the valve should be non-reactive with the solute and the solvent. The compatibility testing of these piping and the valve material should be done at the extreme or the elevated conditions of pressure and temperature, because during the extraction, whole unit is exposed to high pressure and temperature conditions. And once the material is exposed to higher temperature and pressure conditions, through which the solvent is flowing, and we know that at these elevated conditions, solvents sometimes become more aggressive in its solubility and its reactivity. Therefore, compatibility testing of the material should always be done at the elevated conditions. The material, whatever you are using, should have a high strength, which will help in withstanding the high pressure and temperature conditions during the process. The diameter of the piping that has to be used, again, should be optimum as per the flow requirement as well as the pressure conditions, because of the obvious reasons which I have already discussed. High pressure couplings should be used, because couplings are largely used to connect the two pipings, and this is one of the major factor or the areas where leakage occurs. So whatever coupling you are using, it should be able to withstand those high pressure conditions during the extraction process. So in this image you can see two commercial grade couplings. One is Durolock, which is on the left side of the picture, and second one is the Grey Lock, and both these couplings have different mechanism to hold the pipelines, to join the two pipes. Now coming back to the valves that are used in the supercritical fluid unit, then depending upon their usage, their effect, we have isolation valves and the flow control valves. Isolation valves are to stop the flow rate, to cut off one of the vessels, as we discussed in the industrial setup of a supercritical fluid unit, whereas the flow control valves are used to maintain the flow rate of the solvent. If we look into the structure of the isolation valves, they have a metal sealing surface, and therefore whatever metal we are using, it should be able to withstand the pressure and temperature condition. Further, that metal should have a very low coefficient of friction, because we cannot use lubricants in such kind of extraction units. And we can also have certain special coatings on the metal surfaces in order to increase their life, in order to decrease their wear and tear. It has also been found when two different metals are used in the isolation valves, or their oxides or carbides are used with which are having a high hardness values, they give you better results in comparison to the valves that are manufactured by the same metal on metal sheet surfaces. Whereas the flow control valves are now becoming valves of choice in supercritical fluid extraction industry. because of certain obvious reason, because with using these valves you can control the flow rate and also you can stop the flow rate. And the seals that are used in these control valves, they form the important component. They are important component, and therefore whatever material we are using for the seals of these valves, it should not absorb any kind of solvent or solute. It should be stable at the required pressure and the flow rate, and should not get fractured as the pressure is released, because many times in supercritical fluid extraction, once the material or the extract has to be entered into the separator, the pressure has to be released, or once the extraction is over, pressure has to be released. And it has been observed that certain seals, if they are not properly selected, they get fractured whenever the pressure is released to depressurize the system. So such things should not happen with the seals that are used to make control valves. Now we move on to the last factor, last component of the supercritical fluid unit, that is the control system. And control systems, they, as I have already told you, that these are the systems which help in proper functioning of the system. And these include pressure sensors, temperature sensors, pump and compressor flow rate sensors. So any kind of irregularity in the pressure, temperature, flow rate, these are detected by these sensors, and all the inputs are sent into the control systems. And the control system, as per the design, can shut down the system, they can stop the extraction unit if any kind of irregularity is found in these parameters. Therefore, it is always said that system conditions at startup and shutdown of the process must be thoroughly thought through a HAZOP review. HAZOP review is nothing but hazard operability review, which is a process wherein we review the entire process, its equipment, and any kind of hazard that can occur by using those equipment, those process or those process conditions. So one has to be very careful with this HAZOP review if you want to have a very safe and non-hazardous supercritical fluid extraction unit. So friends, in the next lecture I will be discussing about the parameters that can affect the efficiency of supercritical fluid extraction process. Thank you.